When a situation can be split into different possibilities, we can prove the statement separately in each case. If the statement is true in all cases, then it's true in general. Let's see an example. Consider the theorem that says that in any group of 6 people, there are either 3 mutual acquaintances or 3 mutual strangers. To prove that, let's start by picking one person. Let's call them X. Now let's look at the other 5 people, and then let's focus on the fact that each of these people either knows X or does not know X. By the pigeonhole principle, at least 3 must fall into one of these two sets. Let's briefly see why. For example, if 0 people know X, then 5 people do not know X. If one person is in the set of people who know X, then 4 people are in the set of people who do not know X. And so on. We have 2, 3, 3, 2, 4, 1, and 5, 0. These are all the possible scenarios, and as you can see, either at least 3 people do not know X, or at least 3 people do know X. Or, said in a different way, by the pigeonhole principle, given that there are only 2 categories, at least 3 must fall into one of these 2 categories. So, we can split our proof in 2 cases. Case 1 is at least 3 of the people from the group know X, and case 2 is at least 3 of them do not know X. These 2 cases, as we said, cover all possibilities. Let's first look at case 1. At least 3 people know X. Inside case 1, we can think of subcases. First one is, none of the 3 people know each other. If this is true, then these 3 form a group of 3 strangers. And subcase 1.2, at least 2 of them know each other. If this is true, then these 2 people, together with X, form a group of 3 acquaintances. And this covers all possibilities in case 1. Either none of them know each other, or at least 2 of them know each other. And then there's case 2. At least 3 of the people do not know X, which are these scenarios. Now, this can also be split into 2 subcases. Subcase 2.1 is all 3 of them know each other. So by themselves, they form a group of 3 acquaintances. And 2.2 is at least 2 of them do not know each other. And since they are inside case 2 where people do not know X, they form a group of 3 people who do not know each other with X. And with that, we cover all possibilities. In every possible case, the theorem is satisfied, which means that in any group of 6 people, there must be either 3 mutual acquaintances or 3 mutual strangers. In a nutshell, the power of the proof by cases is that it lets you break a problem into possibilities, prove each one of them, and since the cases are exhaustive, the conclusion holds for all situations.